Hey there guys. In this video we're going to start talking about linear equation word problems and how we can use what we know about linear equations and the different forms to set up and solve word problems. And so this is going to be a two-day lesson. We'll start with word problems that focus on slope, intercept, and standard form in this video, and then move on to other word problems in the next video. So slope-intercept word problems. We want to use slope-intercept form anytime our word problem gives us a rate of change, which we will use as our m value, and a starting point, which we will use as our b value or y-intercept. Okay, so a rate of change and a starting point is when we're going to use slope-intercept form. So looking at problem 1, it says you and your friends plan to attend the county fair this weekend. The admission to the fair is $5 and the cost per ride is 50 cents. If your parents gave you $20, write and solve a linear equation to find how many rides you can go on. Okay, so this is a word problem that gives us both a rate of change and a starting point. The rate of change is the cost per ride. Okay, the cost per ride we can see is 50 cents. So every time you go on a ride, you increase your cost by 50 cents. Okay, so that's how you can tell you have a rate of change there, is if your cost or the amount depends on how many times you do something or how many things you buy. Okay, so 50 cents is our rate of change. We also have a starting point, and the starting point is simply the admission to the fair. Okay, it costs $5 to begin with to get into the fair. Okay, so that is our b value. The starting point, $5. So using those two values there, we can write an equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So our equation will be y equals 0.5x plus 5. Okay, so when I ask you to write a linear equation, this is what I'm looking for. Y equals 0.5x plus 5. It also tells us to solve the linear equation assuming our parents or your parents give you $20. Okay, so if your parents give you $20, you need to find how many rides you can go on. Well, the number of rides is going to be our x value in this equation. And the $20, okay, the $20 is the amount that we've been given. That's going to be the y value. So we're going to substitute that $20 in for y into our equation here. Okay, so here's how this will look. We'll take our 20, put it in for y, and then everything else is going to stay the same. 20 equals 0.5x plus 5, and now we're going to solve this equation for x. So to do that, I need to subtract 5 from both sides of the equation. 20 minus 5 is 15. And to solve for x, I need to divide by 0.5. 15 divided by 5 is 3. 15 divided by 0.5 is actually 30. So this tells us that if our parents give us $20, then we can go on 30 rides. $5 for the admission fee, and then $15 more for the remaining rides. Okay, number 2 will have a similar problem. It says, while your family is visiting Deep Creek Lake, you and your mother decide to go boating. The rangers charge $6.50 per hour in addition to a $25 deposit to rent a canoe. If you wish to rent the canoe from 12:30 to 3:30 p.m., write and solve a linear equation to find the total cost to rent the canoe. So this is another example where we have a rate of change and a starting point. So let's look at our rate of change first. The rate of change is $6.50 per hour. Okay, per is a good word that will show you where your rate of change is. Okay, anytime you see that word per, we had per ride up in number 1, per hour here in number 2. That shows you where the rate of change is. So m is equal to 6.5 or 6.50. You have a starting point as well. Your starting point in this case is the deposits. You have to pay $25 to begin with, to start with, to get the canoe. So that is our b value. B is 25. So our linear equation will be y equals 6.5x plus 25. Okay, so now in this case, we have to find the total cost. Okay, we want to find the total cost. Well, when you're finding the total cost or the total amount, you're finding the y value. And number one, I told you what the total cost was. I told you you were getting $20 and you had to find the x value, the number of rides. Okay, in this problem, you're finding the total cost, and I'm telling you how many hours, which is your x value, you're renting the canoe from. So we're renting the canoe from 12:30 to 3:30 p.m. 12:30 to 3:30 p.m. You have to think that's 3 hours. So I'm telling you right there that x is equal to 3. Okay, that's 3 hours. And your job is to find the total cost, which is y. So our equation is going to be this. Y equals 6.5 times 3 plus 25. All I'm doing is I'm substituting that 3 there in for x into our equation. So if we do 6.5 times 3 plus 25, we end up getting 44.5. So that tells us that to rent the canoe for 3 hours, in addition to the $25 we originally paid for it, the $6.50 per hour, our total is going to come to $44.50. Okay, number 3 says your parents have decided to buy a new Toyota 4Runner for $25,635. According to the dealer, the car will depreciate in value approximately $3,000 per year. Write and solve a linear equation to find how many years until the car is worth $3,135. Okay, so again, we have a rate of change for this one. Our rate of change is $3,000 per year, but notice this word depreciate. Depreciate means that value is going down. So our car is losing $3,000 per year in value. So the M value in this case is not going to be 3,000, it will be negative 3,000. Okay, and that negative there is because the car is losing value. The starting point is the original price we paid for the car, which was $25,635. So the equation in this case is going to be y equals negative 3,000x plus 25,635. Okay, now let's see what we're trying to find. We're trying to find how many years. Okay, so we're trying to find the amount of time. The amount in time is going to be the x variable in this case. Okay, you have to think back to what we talked about with relations and functions for all these problems. Okay, time is the independent variable. Okay, so that's the x variable, and then money is usually the dependent variable. So anytime I give you the dollar amount, that means I've given you the y value. So I'm asking you to find x when y is, or the car is worth $3,135. So I'm telling you there that y equals $3,135. So we're going to take our equation again. I'm going to substitute $3,135 in here for y. And then our job is going to be to find x. Okay, so we'll need to subtract 25,635 from both sides. When I do this on the left side, I get negative 22,500 using my handy dandy calculator. And then divide by negative 3,000. And remember, a negative divided by a negative is a positive, so we end up getting x equals 7.5. X equals 7.5. That tells us it's 7.5 years for this car to reach a value of $3,135. Okay, so those are slope-intercept problems. Again, when you're given a rate of change and a starting point, that's when you want to use slope-intercept form. Now we're going to look at standard form problems. And standard form problems, we use standard form whenever the problem relates to different objects. Okay, two different objects is our cue to use standard form. So number 4 says Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill came to $7.80. If enchiladas were $2 each, write and solve a linear equation to find the cost of each taco. So we're going to write a couple of let statements here. We're going to say let x equal cost of tacos and y equal cost of enchiladas. Okay, so we know tacos. He ordered 2 tacos, so the cost of the tacos is going to be 2 times, the total cost of the tacos, excuse me, will be 2 times x, because it's x dollars per taco, 2 tacos. And he ordered 3 enchiladas, so the total cost for the enchiladas is going to be 3 times y. So if you take the cost for both tacos plus the cost for both enchiladas, that's going to equal the total cost of the bill, which we see was $7.80. So we can write a standard form equation. Again, standard form is ax plus by equals c. That just says 2x plus 3y equals the total cost, which was $7.80. So this right here is your equation, again in standard form. And so now let's look at the second part of the problem, what we're given. We're told that enchiladas were $2 each. So now it's telling us that enchiladas, which is our y value, is telling us y equals 2. So I'm going to take this equation, rewrite it, but I'm going to substitute a 2 in for y. So this is 2x plus 3 times 2 equals 7.8. I need to solve this equation now for x because I want to find the cost of each taco. So this is 2x plus 6 equals 7.8. I need to subtract 6 from both sides. That gives me 2x equals 1.8. And if I divide 1.8 by 2, I get x equals 0.9. So that tells me that each taco costs 90 cents. Okay, number 5 says tickets at a school play cost $4 in advance or $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. So again, we're relating two different objects. We're relating x, which we can say is number of advance tickets, and y, which you can say is number at the door. Okay, we know it costs $4 for advance tickets, so 4 times the number sold, 4x, would be the total for advance tickets. $5 at the door, so add 5y, 5 times the number at the door, and you get the total ticket sales. Total ticket sales we know was $440. So this is our equation right here. We are given that no tickets were sold in advance. So that's telling us that x is equal to 0, and we need to find how many were sold at the door. So we need to find y. So taking this equation, I'm going to rewrite it. I'm going to substitute 0 in for x though. Four times 0 is just 0, so this goes away. So I get 5y equals 440, and solving this for y, I get 88. So that tells us that 88 tickets were sold at the door. Okay, for the last problem, it says Karen's piggy bank has all dimes and quarters. The total value of the money in her piggy bank is $11.40. If Karen has 36 quarters, write and solve a linear equation to find the number of dimes she has. Okay, so again, two different objects are being related in this case. We can say x is the number of dimes, and y is the number of quarters. Well, you know the value of dimes, you know the value of quarters, okay? You know dimes are 10 cents a piece, okay? So we can say that 0.1, which is how we represent 10 cents in dollars, okay? Or 0.10x would be the total amount of money in dimes. And we can say also that 0.25, which is the total amount in dollars of a quarter, times y is the total dollar amount for quarters, since quarters are 25 cents a piece. If you add those two subtotals together, our total in the piggy bank is $11.40. So this is actually our equation here, 0.10x plus 0.25y equals 11.4. We're told that Karen has 36 quarters, so we know that y is equal to 36, so our job is going to be to find x, find the number of dimes she has. So we'll take the equation. We're keeping x, we're plugging in 36 for y, and we are solving the equation. So this gives us 0.10x plus 0.25 times 36 is 9 equals 11.4. If I subtract 9 from both sides, I get 0.10x equals 2.4. And then dividing both sides by 0.1, I get x equals 24. So this tells us that Karen has 24 dimes. As always, if you have any questions over this video, be sure to ask those the next time I see you in class. Until then, folks, have a nice day. You're all wonderful people. Take care.